All right, number 2, we want to find the 6 trig functions for the given angle. So here we're shown, it's kind of hard to get the whole picture up here, but we're shown an angle. Okay, so they started here, went all the way around. So it's bigger than 360. That's not the most important part. The most important part is the ordered pair for the angle that we have here. So based on this angle and its orientation, you have an ordered pair. I'm just going to stop it right here. You have this ordered pair 5, 12. And the way you need to see this is an x value and a y value. So that means if we go out 5 and up 12, because it's both positive, that gives us this right triangle shape here. So that means that this side is 5, this side is 12, and here we're going to call this angle alpha right here. And based on what we have, we're going to get all 6 trig functions. So you want to refer to your unit circle. I'm going to write them all out this first time. Sine of an angle. So they might change this symbol. This is theta. They're using alpha, which I'll do that when I actually do the 6 trig functions. Sine is opposite over hypotenuse. I'm just going to abbreviate with O and H. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Then you have the reciprocal identities. So you have cosecant CSC is equal to just the reverse of this, so it'll be hypotenuse over opposite. Secant SEC is equal to the reverse of this, or the reciprocal of this, which is hypotenuse over adjacent. And then tangent is counterpart is cotangent, and it is equal to adjacent over opposite. All right, so these are our 6 trig functions. We're looking for these values. So we need the hypotenuse if I'm going to do any of these 4. All right, so from what I have opposite and adjacent. I can do tangent and cotangent, but I need the hypotenuse. This is a right triangle. So we have 2 sides. We can use Pythagorean theorem to find the missing side. The long side is always C. So if we do a squared plus b squared equals c squared, we will be plugging in 5 squared plus 12 squared equals c squared. That gives us 25 plus 144 equals c squared, and that gives us 169 equals c squared. And then if you square root both sides to get c by itself, square root of 169 is 13 equals c. So the missing side is 13. All right, based on this, we can fill the rest of this in. All right. So I'm going to say sine of alpha equals, here's alpha, opposite over hypotenuse. So that'd be opposite is 12, hypotenuse 13. So 12 over 13. And then CSC of alpha is going to be 13 over 12. You just flip it. All right, cosine of alpha is equal to adjacent over hypotenuse. So adjacent is the same side based on where the angle is, 5 over 13. That means SEC for secant is equal to 13 over 5. Tangent, opposite over adjacent, so opposite is 12 over adjacent is 5. And then cotangent of alpha, we'll just reverse that, so 5 over 12. And that's cutting off at the bottom. All right, so there are our 6 trig functions. That's what we want to put in here. Sine 12 divided by 13. Cosine 5 divided by 13. Tangent is going to be 12 divided by 5. Cosecant 13 divided by 12. Once you have them all, they're not that bad to plug in. Secant is 13 divided by 5. And then cotangent is 5 divided by 12.